Without further ado, I'll turn it over to Bryan.
Thank you. First of all, does everybody have a handout? This is how to install Python on your own computer. If you'd like to do that, it's really easy, at least the way I found here. And it's, for next time, it would be good if you actually have Python on your computer. So this is your homework. Whoops. So what we're going to do today, though, is just go over some really basic stuff, and I'll try to, show it instead of just tell it. How many people already have some Python experience? Okay. So hopefully this won't bore you if you already know some stuff. And feel free to ask questions at any time, or if you have seen a different way to do something, you want to ask about it, go ahead. So just to recap some stuff from last time about what is Python. It's a general purpose programming language. It's not specific to a particular task like MATLAB is, or GEMPACK or something. It's designed to be very readable and very easy and fun to program in. It is an interpreted language, which means as soon as you type something, it does it, as opposed to a compiled language, which you type something, you save it, you compile it, you save that, you run that, and there's many steps, and you have to deal with a lot of overhead. So because it's interpreted, you can use it interactively. It'll respond right away, or you can save your code and run it later with the interpreter offline. It's also very modular, which is one of the reasons it's very popular. It's very flexible. There's a core language that you can extend with all these different modules. And we'll talk more about that in a minute. Another reason it's popular is because it's free. You can go out and get it, download it, not pay anything. And it's has a big community of people working on it, and there's a lot of activity and improvements happening all the time, and so it's just this big thing. Even though it's been around a long time, the actual language was started in 1991, and the name Python comes from Monty Python, as in the comedy troupe. Okay, so now it didn't start out as a language for science or scientific computing. It's just a language, a programming language. But what happened is over time, people started writing modules, these extensibility parts that add functionality to the language. They wrote these modules that started to do useful things that scientific data analysis and model running and that kind of stuff can be done. So the modules, they're a big part of this. I mean, if you just had the core language, you could do some things, but it would be a lot harder. The modules make things easier and add a lot of depth to things. So let's see. Mainly what I'm going to be talking about is the collection of modules called SciPy, Scientific Python, and those are the core of the scientific computing part of Python. So there's NumPy, which gives you numerical arrays, very similar to matrices in MATLAB. And then you have Matplotlib and PyPlot, which let you make figures, very similar to MATLAB. Basically, they said, we're used to MATLAB, but it costs too much and we don't like the way it works, so we're going to do all that same stuff in Python. So a lot of the scientific stuff in Python is sort of similar, not identical, but similar to how it's done in MATLAB. There's another one called Pandas, which I probably won't get to this time. Hopefully next time I can show that a little bit. That has more data handling stuff for larger data sets and stuff. So if you take SciPy and you put it with Python, you get some powerful programming abilities. Just want to show a couple of web pages I came across. This one's talking about how Python is like the most popular introductory language for computer science now. And then Nature magazine is telling scientists to try it. So I think that's pretty interesting. This one over here was from February of this year. All right, so just to cover what we're talking about today, it's going to be how to get started with Python on your own, certain commands and concepts and modules that you need to have some familiarity with. I'll show examples for loading and saving data. This is like really basic stuff. Examples for creating plots and saving the images. And hopefully I'll get to also where you can go for more, because there's a lot of stuff out in the world, and I'm only going to be able to cover a very small part. And then in 2 weeks, that's where we're going to get a little more in depth and go into just examples. One of the things I'd like you to do is, my email address is on this handout. Send me ideas for examples that you want to see. I'll come up with some if I don't hear from anyone, but you know, the more interactive this is, the better. So if you have something you know how to do in MATLAB, say, or some other language, and you want to know how to do it in Python, you can offer that as a suggestion. So
that's an invitation for Bryan to help you do your research.
It's going to happen anyway. Okay. So in order to use Python, you have to have Python. The handout goes into the details of installing something called Anaconda, obviously another snake name. Anaconda is a distribution of Python. It is, because Python is free software, and all these modules that I'm going to talk about, they're all free, they're all out there. But if you wanted to go collect them all and put them on your computer, it would take a while, and you'd have a lot of hurdles you'd have to jump over, and it wouldn't be fun. So these distributions, they go out and do all this work for you, and they make it an easy download and click on it kind of installer that gives you pretty much everything you need. Not 100%, but enough that you can start. And there's also some infrastructure and tools that you can go out and fetch other pieces that you might need. Because they don't give you everything, because they don't know exactly what you need, but they give you a lot of it. So the thing is that these distributions, they're made by companies, for-profit companies. The distributions themselves are free, but they're kind of like a hook to try to get you to buy something of theirs. And someday they might not be free, but for now they are. And if they did become not free, then someone would come along and make a free one. So for now, I recommend this Anaconda one. It's really, well, it's complete, it's really easy. Even though it looks like there's a lot of instructions, it's really not that big a deal to install it. You basically pick the one you want to download it, run it, and you've got it. You've got everything I'm going to show you. Okay, let's move to the next thing. So one issue so Python is a developing thing. These modules, this code that's out there for it, it's all under development and under work, so things change over time. Python's been around a long time. It's had version 1 is like long gone, but version 2 has been around for many years. Version 3 has been around for 5 years or so, and they're trying to get everybody to switch from using 2 to 3, but there's always a lot of inertia with that kind of thing. So when you go to get the Anaconda stuff, you're going to have an option between version 2 and version 3. So I'm going to recommend version 3 because it's newer. There are a few modules out there that you might want to use that are not yet available for 3. So if that happens, you can always go back to 2, but I would recommend starting with 3 because that's the way the future is, the way forward. In fact, the version of 2 that's out now, version 2.7, is the last major 2 version they're going to have. So they're saying, we're done, move over to 3. So anyway, so that it's on the sheet to do that, but I just wanted to mention it. Because you may end up, if you end up writing some Python code and getting further in it, you may encounter a situation where you need to switch back to 2. With Anaconda, it lets you have both, actually, if you want. So it's not that big a deal, but something you need to know about. Okay, so I'm just going to show you these things. Oh, let's start with this. Do you see the URL here? try.jupyter.org. You can do that right now on your laptops. You can go and you will have access to Python right then and there. And in fact, I'll do it too, just to show what we're talking about. Oh, what's the problem? I can't spell. Jupyter. It's like Jupiter, but spelled like Python. Okay, so this is a really cool website that people are essentially donating server time to let you play with Python. Now the thing is that you get this server and you can play with it, but if you're idle for 10 minutes, it kills what you've done. And it's not for saving things, it's not for doing your real work, it's for playing around. Okay, so this is something you can mess around with today while we're exploring. Then you go to the handout, you install the real thing on your computer so that you can save things and use your own data. There's no way to get your own data into this. But if you go here, then what you want to do is go to Welcome to Python. Well, I guess there is some data here. What's in there? Oh, so there's some data that they've made available. I haven't looked at that. But if we go here, come on. So this is called the Jupyter Notebook. And it's like one of the really futuristic things about Python nowadays. It's a web page that has in it a connection to an actual Python running program. And you can type code into it and execute it within your web browser. And you can also interchange between like text and code. And so what you do, well, it says right here what to do. Run some Python code. So you click on this box that has some code in it. You press Shift Enter, and it computes for a minute. The little star shows you that it was working. The 1 means it's finished, and now it has created this figure. So you can see, in this much code, you can make this figure. And you are free to sit there at your desk and edit this and play with this and see what it does. And you're not going to hurt anything or break anything and just have fun. But I'm going to go through sort of the commands that you kind of need to know to get anywhere with this. But again, if you're working on this and you don't do anything for 10 minutes, it's going to erase what you've done. I think you might be able to save your work. Yeah, you can download this if you want. If you download the IPython notebook, which is, IPython is another name for Jupyter. If you download the IPYNB, then you can save that on your computer, and then once you have your own Python, you can bring it back up and run it. So anyway, this is, if you have your laptop here today, you can play with this. But I'm not going to mess with this particular one. I have my own notebook that I'm going to use. All right, so, all right, let's see here. So the notebook is a way to interact directly with Python. There's other ways to talk to Python. Let me show you. So here we are. Oops, actually, let's do that. And we will shrink this. And then grow it. Is that readable? Okay. So what I can do is I can just type Python. Wait, I have to do something here. So if I type Python, it gives me this command prompt and says, hi, I'm Python. What do you want me to do? So you can start typing Python commands, like print, hi there. And it does what you say. But this is like the least useful environment to interact with. This is really the one meant to run non-interactive programs. So let's show that. So if I so if I make a file, test.py. So if this is an empty text file. I'm using my favorite text editor. You can use whatever one you like. And you can start typing commands in here. So you can say print hello world from Python. And you save this. And then you say Python test.py. And it runs your program. So that is the non-interactive way. That is the save your code, run your code way, which is very good if you have stuff that you need to reuse a lot, and I feel like you want to do the interactive stuff when you're exploring, and then once you've gotten everything sort of figured out, then you write it into a script so that you sort of keep a permanent copy of that. So that's one way to do it. You can also type Jupyter test.py, I think. Nope, never mind, that doesn't work. I think if you do Jupyter, what? Console. Okay, so I forgot. So Jupyter is like the notebook, but the notebook is part of Jupyter. Jupyter is another way of talking to Python, and in here it's always going to be interactive. So you can say a equals 12, print a, whoops, I meant lowercase a, and it does what you say. You can say run test.py. The percent means this is not a Python command, this is a Jupyter command. And then it reads the file and it does what it says. So I'm not going to be using these scripts a lot right now because I want to do the interactive stuff, but it's just to show you how that works. Are there any questions right now?
So is Jupyter the same thing as IPython?
As what?
IPython?
Yeah, IPython has been renamed to Jupyter. So IPython was the interactive Python. What they've done is they've generalized it. So Jupyter can now do Python through IPython, but Jupyter can also do other languages like R and Julia and other stuff. So Jupyter has like gotten so big that it's more than Python even. So Jupyter is this environment that you run things, but it defaults to Python typically. So it's been called IPython for a while. They just recently renamed it, so you're going to see both names. Any other questions? Yes.
So with Anaconda, you mentioned that there are like different modules,
Mm-hmm.
just SciPy and some other. If like I want to run ArcPy from ArcGIS, can I incorporate that in Anaconda or?
I'm sure you can, but I'm not sure how right now, because I think the ArcPy comes with the ArcGIS software. So I know you just have to put it in the right place.
And also I think there's a problem with the 64 and 32 bit, plus the ArcPy is in different
Of course. So when you start dealing with code that's written by a third party, you have these issues. So in that case, you would want to install the Python 2.7 32-bit, and then you could, I don't know exactly the instructions, but you would take the ArcPy stuff and stick it in the right place so that the Anaconda could see it.
Or is there any way Anaconda do the GIS or incorporate the GIS data?
Maybe. There may be other modules. My understanding is that ArcGIS is proprietary, so it's probably not going to be available through the normal channels. But I think there are other GIS modules out there. So I'll write that down as something to look into for next time. Any other questions right now? All right. Let's see. So going back to here. Oh, Spider, yes. Another thing that comes with Anaconda is Spider, which is what's called an integrated development environment. This is kind of like when you run MATLAB and it brings up this big window with all these sub-windows and things. This is the Python version of that, and it'll take it a minute to load. But what this is like a full environment for you to edit Python code, run it, debug it, all kinds of stuff like that. So this is yet another way to interact with Python. So here, this window here is a text editor, which is Python intelligent. So it knows when what you're typing and what it means, and it can help you type it faster. And then over here is like IPython or Jupyter. You can type things here and get immediate results. And then up here is like where you can find information about stuff as you type it. So you can, if you're not sure how a particular module works, you can look it up on the right side. I haven't used this a whole lot, but it looks promising. So it's just another option. Okay, let's see. I'll just minimize that. Okay, what else do we have? So now the notebook. Yeah, so this is not where I want to be. Okay, so if I do Jupyter notebook, what that does is it starts running the notebook. So what the notebook is, it's really a web server that it runs on your own computer. And then it brings up your web browser to connect to that web server. And the web server underneath talks to Python. But, what's it doing? 8891. Okay, so I'm going to actually use the other browser for this. So this is the Jupyter notebook where it starts, and it gives you your files and you can look at them. So anything that is the I, P, Y, and B is a notebook, and you can open those and play with them. So let's start with basic Python. So what this has is a collection of commands that I've typed in and text that I've done, and we can go through and edit them and run them and see what they do. So let's start with that. So we're going to start with really basic things, and again, stop me if you have questions. So the first thing usually you want to know how to do is print things. And what I'm just going to do is go through and hit the shift return in each one, and it's going to execute when I do that. So you see the 1 here means that this one has been executed, and it was the first one to be executed. That's important because if you wanted to, you could execute these out of order. And if you did that, what happens is the outcome of each one affects the ones you do later. They're all in the same memory. So we said print hello world, and it printed hello world. This is always the first program anybody does in a computer language. So a couple of things here. There's the print function, which you send it something and it does something with it. And then the thing that we're sending it is a string. It has these quotation marks. A string is just some text, some letters and numbers that you want to display or do something with. So we tell it to print that and it prints it. Okay, great. That's not very useful yet, but it's something. So now we have some variables. So this is where you have information and you want to store it somewhere. So I have a variable called message, and that is equal to this string, hello world. Oh, and these things here are comments. If you're not used to that in a language, that is stuff meant for the humans, not for the computer. So anything after the hash mark is ignored by Python. It's just for our readability. You can have an integer like this one, and you can have floating point numbers. So these are like the three really basic stuff. And notice that I'm trying to use good names for these, not just blah and X and stuff like that. You always want to name things well, and especially in science contexts, you probably want to indicate units somewhere. So that's why I put this. It's in Fahrenheit for temperature. So if I execute this, come on. Oh, right. It's not printing anything, it's just storing things. So if we want to see them, we have to print them. So let's print these. Let's do that. So this one's been run as second, this one's been run third. First, it prints the message. So that says hello world. Then it prints this thing, the answer to the ultimate question is, and then the answer. So that creates this one line where it's got two pieces of information on the same line. The string that I gave it, followed by the number that was stored in the answer. Let me scroll up. And then I created another string here just to represent the units in a human readable way. Oh wow, this is scrolling off here. Let's see. All right, I'll have to. So what I've got here is I've got this string. This string here is called a format string. It contains text that you want to print and instructions for including other information. So the other information is represented by these curly braces here. So curly brace 0 means the first thing that you give it, and curly brace 1 means the second thing that you give it. And what I mean by giving it is that I call this dot format. So it's string dot format, and then the information that we want to stick in the string. So I'm giving it this body temperature F as the first thing, and then I'm giving it units as the second thing. So units is going to go here, and body temp F is going to go here. Now the colon point to F are instructions for how I want the body temp F to be shown. So what that's saying is that you should write that number with two places after the decimal point. That's often useful if you want numbers to line up and stuff like that. So these are examples of different ways you can output stuff. Any questions here? Confusion?
The string that was executed, the last one there, it has, oh, I see, there's degrees Fahrenheit. I didn't see where you specified the value.
So units was, I just threw that in here to try to keep this short, but it's still not short enough. Now you can also do it this way. Let me show that. So format string equals so this is another way to do it, where you could actually store the format string in another variable and then use that to do the formatting. It doesn't matter. It does make it a little easier to read, though. It's the same behavior, though. Any other questions? Okay. Let's do a little math. So let's convert the Fahrenheit to Celsius. So this has all the basics of math. You've got parentheses, you've got subtraction, multiplication, and division. You can also do addition, of course. So that's pretty straightforward, I think. And then if I print this, I got to run it. So that gives us 37 degrees Celsius. Now, because this is an interactive thing, you don't actually have to print everything to see it. So if you just type a variable on a line by itself and run it, it shows you that result as out. So it's like, this was the input, this was the output. When you use print, it doesn't say out. It's just doing what you told it to do. So this is what you told it to do, and this is the sort of implicit output that you want to see. But if you have two such things like that, it only shows you the last one. So this does not print the message followed by the answer plus 3, it just prints the last line. So if you did want multiple things to show up, you would need to use print for that. It's just different ways of interacting with the notebook, basically. All right. Questions? And feel free to, you can type this kind of stuff into the try Jupyter thing and play with it and do whatever you want. All right, so, well, let me show you something about ordering. So this is specific to the way the notebook works. If I were to go up here to this one that I've already executed and hit Shift-Enter again, you see that the 2 turned into an 8 here. That means this cell has now been executed 8th in the sequence. So even though that's not the order they're presented on the screen, that's the order that Python remembers things. So you can actually go back and edit these and re-execute them, and that will update the situation that Python sees. So I didn't change anything, so it really made no effect. But if I, for example, change this to 24 and then did it, it would change that value of the answer. Now if you go down here to where I had done this, whoops, let me scroll up. It still shows 42 because that's what it was at the time that I ran it. But if I run it again, now it's updated to the new value. So all these things are in memory somewhere, and you're messing around with what's in memory, and so that can affect the outputs that you're seeing. All right, let's see here. Now we have to get into slightly more complicated things, but these are the things that start to make Python really useful and simple compared to some other languages. So one of the main types in Python is the list. So this is, instead of a single value, it's a collection. So you see the square brackets and commas. So I'm storing 4 separate numbers into temps C. Doesn't have to be 4, it could be 4,000, whatever. And then this one is demonstrating that they don't all have to be the same kind of thing. This one's a string, this one's a floating point, and this one's an integer. They're all different. But that's okay. So another way to do this, I should have put this in here. I could do list 3 equals, so that's an empty list, contains nothing. I can say list 3 append the answer, and list 3 append, I don't know, 6, 5, 4, 3, 2, 1. So if I run that, and then let's stick here, print list 3. Okay, so I've printed these 5 things. So let's look at that. You've got temps C, which was these 4 numbers. So it prints those 4 numbers, just as you'd expect. Then what I'm doing here is I'm saying the length of temps C equals, and I'm calling the len function, L-E-N, short for length. So when you call that and you give it a list, it tells you how many things are in the list. So since that's included in the print, then it's sticking that here. So length of temp C equals 4. So the 4 is coming from len. Then I print arbitrary list, which is just this list of things, and you can see it's putting quotes around the things that are strings, and it's showing everything, the different types, the integer and the floating point. And doing the same thing here with length of that list, you see the length of that list is 3, 1, 2, 3. And then I'm printing list 3, which I built in a different way, and that one is here. Any questions about that? Okay.
So the way it's displaying the list is as a row vector?
Right. Well, so this list is not the one you use for mathematical stuff. This is a generic way of storing information. You will use lists so you could have lists of lists. So you could have something, we could call this a vector, or a matrix, and I could say 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I've got here a list containing 3 lists, and each list contains 3 things. You might think that that would be useful for math, but that's too cumbersome. We'll get to the real thing for that in a minute, but the concept is very similar to what we'll see in a minute. So if we do print matrix, it prints that, and if we did, I'm going to insert a cell below here and type matrix. Yeah, it's the same thing. Sometimes it prints them differently. Never mind. So yeah, it's not a row or a column, it's a list. And we'll come to rows and columns in a minute. Another thing is, if you have a list, you probably want to grab things out of the list instead of dealing with the entire list. So if you use square brackets after the list name and put in an index, then that allows you to retrieve the item at that location. But this may be non-intuitive to some people. Python starts counting at 0. So the first thing in the list is at location 0. The second thing in the list is at location 1. So it's like an offset. How many away from the beginning is it? So you got to remember that, because like in Fortran and MATLAB and stuff, they start at 1. In Python, they start at 0. It's going to throw you off if you're not careful. So temps C of 0 should give us the first number in the list. And then what I've got here is 1:3. And if you're used to MATLAB, you might recognize that idea of starting at 1 and going to 3. But Python's a little tricky there. Let's execute this so I can show you. So, whoops. I want to see, all right, so remember this one here is temp C. So if I say 0th that gives me 12.3, which is the first one. If I say 1:3, you might expect to see this one, and this one. But Python doesn't do that. It gives us this one and this one. Because what Python does, and there's a programming reason for this, it never gives you the last one. You go up to, but not including that one. So 1:3 means start at 1, go up to, but not getting to 3. So that means you get 1 and 2. And so if that's 0, and that's 1, and that's 2, then you get those two as your answer. It's a little weird at first, but it's very consistent with the way Python does a lot of different things, so it's important that it works that way. Now this one, also if you know MATLAB, you know there's a way to specify the beginning of the interval, the end of the interval, and a skip, so you don't get every single one. Now in MATLAB, the skip goes in between, but in Python, the skip goes on the outside. So this is where you start, this is where you end, and this is how much you skip. But what does a -1 mean? -1 means from the end. So -1 means the last one. So I'm saying I want to go from 0 to the last one, skipping by 2s. So that gives you this one, then we skip that one, we do that one, we skip that one, there's nothing left, so we're done. So it gives you the first and the third. Yes?
If there was another one, would it give it to you, or because your end of your range is -1, would it give it to you?
Let's find out. Let's go up here and add another one. Make it hot. So I have to re-execute this one for that to show up. I'll re-execute this one just so we can see. There's the 88. Do this one again. Oh, it didn't do it. So I couldn't remember which way it would go actually. I think that the -1 says that one, so it never does the last one. But I think, if I remember right, we can do this. If I don't say anything at all, that means all of them. In fact, I don't even have to put the 0 in this case. Colon means all of them. And then the 2 is just saying every other one. So it's a little, you'll have to play with that to get used to it, but that's just how it is. Any other questions so far? Okay. All right, dictionaries. That's the other big deal in Python. This is the kind of thing that in other programming languages like C or Fortran would take many lines of code and be very cumbersome to deal with. In Python, it's quick and easy. So what a dictionary is, it's kind of like a list, except you label the things in the list. So in this case, I create an empty dictionary with the curly braces instead of the square brackets. And this is kind of like up here, like when I said bracket 0, I meant the first element in the list, except this isn't a list, it's a labeled list, kind of. So instead of giving numbers here, I give labels. And the labels can be anything. The labels can be numbers, but they're not indexes. They're just arbitrary numbers. So I could also say quantities 5,000 equals 5,000. So what I'm doing is I'm creating an entry for each one of these lines. I'm creating an entry in the dictionary, and I'm saying I want to associate with this thing this value. And I want to associate with this thing that value. And they don't even have to be numbers. You know, you could say something like that. And so when I print it, I get this curly brace thing that says the label of milk goes with the value of 1, the label of eggs goes with the value of 6, the label 5,000 goes with the string 5,000, and the label bread goes with 0. You'll notice they're not in the same order that we put them. The order is arbitrary.
Oh, so that would change like every time you execute? Or?
Potentially. You can't rely on that order. It's the order that it appears in the computer's RAM, which is based on a lot of different things. So, but usually you don't use one of these for ordering purposes. I think there is a variation that you can specify order, but I've never used that. But what you do with this is like for looking up things. It's a dictionary. So it's like, well, I didn't know, like instead of trying to remember that milk is the first one in the list, for example, I don't have to remember that. I can just say, I want the one that goes with milk in my dictionary. So I can look it up. So if I say print quantities bracket bread, then that prints the number or the value that was associated with bread, which is 0. Now then I try to look up something that's not in the dictionary. Oh, and I get an error. So this is telling me, this is the type of error you'll see in Python. It's not super user-friendly, but you can start to get some ideas. Here it's trying to show you the line of code that it doesn't like. It's saying, okay, this is the one that I had a problem with, and then it says key error soda. So you have to know, to understand that keys are what these things are. So key error means that key is not in the dictionary. So you can always Google that or something, you know. Now, it's not clear until you start doing things with these why they're useful, but the combination of list and dictionary, you can do a whole lot of different stuff with that. So to illustrate, I'm going to do this. Well, let's go through the code first. So temp data is an empty dictionary. I'm adding something called a name and giving it this value. I'm adding something called units, giving it that value, and then a thing called values, and I give it a list. So now I've got a list inside of a dictionary. That's where it starts to get useful. You can start to build these things inside of each other. Then I create another dictionary, and I say data temp equals this whole dictionary. So now I've got a dictionary inside of a dictionary, which has a list. So you can create this whole infrastructure. And then data press is another variable that I would come up with. So it has a name of pressure, it has units of millibars and values of whatever. So the idea is that you could, for example, store information with not just numbers, but also associated useful things. So let me run this. And it prints out kind of ugly, but you can parse it. The outer curly brackets is the entire dictionary. Then press is the label, colon, and that associates with another dictionary, which goes from here to here. And then temp is another dictionary. And then within each one, you can see the name and the values and the units. Who's confused? Any questions? I know it's not completely clear yet, but these are the building blocks of writing code in Python. So the thing is that when you start to use these modules, I haven't used any modules yet. This is just the core language. When you start to use the modules, they take these ideas and run with them. So they do things that are very similar to dictionaries and lists, but aren't quite. They actually have other behaviors and abilities and performance and stuff. So I'll try to show that next. Let's see if there's something in here I have to look at. We did that. Script. Okay, so I need to talk about modules a little bit more. So the modules are these bits of code that get written by people and added onto the language. They extend the functionality in different ways, and the idea is that they're usable not just for one program, but for many. And in order to have the module, you have to install it. Now, if you install Anaconda, it comes with hundreds of modules, but there might be occasionally one or two that it doesn't come with. In fact, the last line of the instructions suggests to install a couple of modules that it doesn't come with, which might be useful. So here are some not necessarily scientific, but very generally useful modules. So the math module gives you things like log and sine and cosine and all that. And then you've got the OS module, which lets you talk to the operating system and find files and things like that. The datetime module lets you deal with dates and times in a semi-sane way. Now the scientific modules, I've mentioned these a little bit. So you've got the NumPy, which gives you numerical arrays. So numerical arrays are like lists, but they're more suited for math and for containing lots of data, like numerical data. You've got the PyPlot, which is for making figures. I'm going to show that. SciPy would be if you need to do actual number crunching. Fourier transforms, optimization, what was the other one? Interpolation, and then like linear algebra type stuff. Pandas is for dealing with spreadsheet-like data. NetCDF4 if you're doing any kind of geophysical data that usually comes in a format like that. And X-ray is a way to deal with that NetCDF data in a little easier way. All right, so the core language is what you get when you start Python. In order to grab one of these modules and make it available, you use the import command. So like if I said import NumPy, then that would make the NumPy module, it would just appear and I could use it. But every time you use something in that module, you have to specify the name of the module and then a dot and then the thing that you're using. Now you could also alias that. So if I said import NumPy as np, which is commonly done, then instead of saying NumPy dot whatever, I say np dot whatever. It's just a way of saving typing. You could also specify a particular thing you want. So I could say from NumPy import ndArray, and then I don't get everything, I just get that. And it doesn't stick the name on it, you just use ndArray.
Right, for that
Yeah.
last command, you need to know the stuff that's inside
Yes.
the module. Is there a way to kind of query?
Well, so yeah, let's see. Let's go to the bottom of this. So I didn't even mention that. So there's a help system. So if I'm interested in the module NumPy, I can ask for help on NumPy. Hello, there we go. So it gives, there's different ways of doing this, but this is like a simple one. So this gives you sort of the rough documentation about NumPy, and so NumPy is pretty big. There's a lot of stuff in it, so there's a lot of text here. But usually, the easiest thing to do is to go find the online documentation. But Python knows what's in there, and it can show you, but it can be a little overwhelming when it shows it to you like this. In fact, look how long this scroll bar is. Yee. So that's probably not the best thing to do, but that demonstrates that there is help. You can, like, if I said import NumPy as np, now it's imported, and I say np dot tab, if I hit the tab key, this is a specific to the way the Jupyter works. It actually gives you the list of things you can type next, which is very big because I'm talking about an entire module. So there's all these different things I could do. So these are different ways of finding out, but it's not, they don't have a great way of like pinpointing exactly what you want. I think.
But the advantage is it saves memory if you're just bringing in that.
Yeah. Like some modules are really big. It takes a while to bring everything in. You're probably not going to do that third one very often, but that's for particular cases. Yeah, good question. Any other questions on importing? All right, let's go to the examples. Oh yeah, let's enlarge this a bit. So this is just one other thing before I get to the other stuff. So if you wanted to write a function, so that would be where you have some code that you want to reuse for a lot of things, then here's how you do it. You say def for define, and the function name, and then the inputs, or parentheses, the inputs, and then a colon. And then you'd have some code here, and then you'd return whatever the function gives back. I didn't show things yet like looping and if statements. I don't know if I'll have time now, but maybe next time I can show that. But so now that I have defined this function, I can call this function. So if I don't run this cell, it won't work. So I run it, then I call it. So now I've converted 20 degrees Celsius to 68 degrees Fahrenheit. Whoops. I think I split this up wrong. Let's go back up here. I need to repeat this line. All right, so here's an interesting thing. So here are my temperatures in Celsius, and if I want to call this function on all of them, I do this sequence. This uses the square brackets to represent a list, but it's instead of the actual items in the list, it's the code to generate the list. So what it says here is for t in temp C, which means go through each thing in temp C and call it t, and then do this for that, for t. So then I call convert C to F on t. So what it's doing is it's automatically looping through the first list, taking each item, sending it into the function, taking the result, and putting that in a new list. So you can see the two lists here. It took 12.3, it ran it through this function, and got back 54.14. And it did the same thing for each value. You don't have to do that too often. This is just to show some of the differences between the basics and the more useful things. Let's skip that. All right, let's... This is a little bit out of sorts here. All right, so let's start with NumPy. And what I'm going to do here is actually load a file. So let's look at this file real quick. No, not that file. This file. So temp data. All right, so these are some temperature numbers that I grabbed from the Rutgers PAM site, which is the a instrumented research facility nearby. These are hourly temperatures from October of 2013. And it's just a list of numbers. So there's no way to see the context of where this came from, but those numbers are in there. And if I go back to my notebook and I do this line here, then I can look at that. I can say temps hourly. And now it's got all these numbers. Whoops. What happened? It just crashed. Dang it. My browser crashed. That is not good. Must have been too big. All right, so let's do this again. And sorry. So this is the first 10 items in the list instead of the whole thing, which apparently crashes the browser. But it's basically a bunch of numbers. But so you see here, it's got, oh, this is too little. It's got the square brackets that the lists had before, but you see wrapped around that is array. So array is the NumPy thing. So I called NumPy load text, and I gave it the name of a text file that has numbers in it. And it read those numbers, and it converted them into numeric values and stored them in this long vector, essentially. And so what I'm going to do is skip over all these lines and go to the bottom because it's easier. So if I say temps hourly dot shape, this is telling me the dimensionality of that variable. So it's saying it's 744 rows and 0 or 1 column, basically. It's a one-dimensional. But I could do this. Temps daily equals temps hourly reshape. Hopefully I'm doing this right. So now temps daily all right, so what I've done here is I took a shape that was 744 lines long, and I said, now rearrange that so it's 31 rows by 24 columns. So now I've made it two-dimensional. And I'm asking for the shape, and it says 31 by 24. And then what I say here, this is like MATLAB, I say, give me the 0th row, which is the first row, and give me all the columns. So with the comma here, I am giving it telling it what I want for each dimension. The first dimension, comma, the second dimension. So it's giving me here the 24 temperature values for the first day in October of 2013. And what it's not showing is all the rest of the rows because it's too much information. So then what I can do, since I've reshaped it, I've made each day have its own row. I take the mean over all the rows and I get the daily mean temperature for every day. So I took some data, I read it, I rearranged it, now I've calculated something useful. Any questions so far?
What does the
Right.
specify?
This is the dimension I want to average over. So that means, so that's the 0th, that's the first dimension. So it's saying essentially average the columns together. For each row, you're going to take the average over the columns for that row. So that way, if I didn't put that, it would probably default to the other way around, and then I would get average hour 1 for each day and average hour 2 and so forth. Yeah, so you do have to specify which dimension you want.
I might be a little slow. So the data file that you read in had hourly.
Yeah, just hourly numbers.
Great. So the first 24 would correspond to day 1.
Yes.
The second set of 24 would correspond to day 2. So how does that square with the syntax that you have there where you reshaped? So you have 31.
You renamed it into something object.
Well, if you have this long list, and what I'm saying is, this is 744, which is 31 times 24.
Right.
So what it's doing is it's taking the first 24
Yeah.
and making that the first thing, and then it's taking the next 24 and making those the next thing, like that. So it's just taking it, and it's so. Whereas the first position is here,
Yeah.
the first position is here,
Sure.
and it's going down here and going to the right here, basically, and then it wraps around when it gets to this one.
Right.
Does that make sense?
Yeah, I guess, so I use ferret.
Yeah.
And in ferret, you would make the first dimension the hour
Right.
dimension, and the second dimension would be the day.
That's because Ferret uses the Fortran ordering of data. It's completely arbitrary, but each language can do it either way. So in Ferret, things are stored essentially down
Yeah.
the columns,
Yeah.
whereas in Python, it's based on C, which stores things in rows first. It's just the order that it is in memory. So yeah, that's a good point. If you're used to Ferret, or I think MATLAB might even be the same as Fortran too, in some ways. So this might be a difference from MATLAB, but I'm not quite sure.
Force that to go the opposite way if you needed to have your data, your matrix transposed essentially.
Well, you could transpose the result. All the type of matrix operations are available. So, any other questions? Okay, so let me see here. Oh, running out of time, goodness. I really thought I'd have lots of extra time. Okay, let's do some plotting. Everybody likes that. Where did I put that? Oh, that's all reading. Okay, here we go. So, wait, before I do that, I'm going to do this. I'm actually going to replace temps daily with its means. So if I say temps daily, now I just get the actual daily temperatures. So what I'm going to do now is let's import, that should be pyplot. So matplotlib is this big module. I'm asking for a piece of it, matplotlib.pyplot. It's actually a module inside of the module. And I'm naming that whole thing as PLT. So whenever you see PLT, I'm referring to pyplot. And then what I'm doing here, so if I have my hourly temperatures, well, no, let's not do that yet. We'll come back to that. PLT.plot temps daily. Come on. Oh, I think I forgot an important thing. Yes, I have to do this percent matplotlib inline tells the notebook to keep the figures in the notebook. So if I do this again, it puts the figure here. So we've made a plot. We have some data, we've made a plot. The bottom, since I didn't give it an x value for the data, it's just using the index. So it's starting at 0 and going to 30. The y is the value in the list. Now if I wanted to plot the hourly temperatures as well, I can do that. But the problem is they don't have a consistent x-axis associated with them. So this one has 30 things in it, or 31, and this one has 740 something. So it's not really helpful. So what I do is I make some x-axes. So the arange function inside of NumPy, you tell it a start and an end and an interval, and it creates a list of numbers that follow those rules. So I'm saying I want the first number to be 1, the last one to be 32, and the ones in between are 1/24. So these are essentially days or fractional days along which my hourly data runs. This one is the same thing, except it's daily data. So if I then put days and hours, now they have consistent x-axis and they go together. So you've got your hourly fluctuating temperatures and you've got your daily means. But now, this isn't right. This is not, well, it's starting at 1 now, but this is starting at 0, so we can do some things. plt.xlim 131, plt.xlabel, day in October 2013. If you're familiar with MATLAB, these function names would look similar. They basically stole them from MATLAB. So now I've got a nice x-axis, I've got labels, I can do, all the stuff you can do with plots, it's all in here. But I just wanted to show. And then the final thing you'd want to do is do save fig, and then October temperatures. So now it's taken that figure and saved it to a file. So now I've got some output. I might, yes?
You saved as a PNG file, but can you save as another file?
Let's try. I don't know. EPS? Okay, that one might be tricky. Let's see. Okay, so open. Oh. Yeah. I don't know if it worked or if the conversion failed. Yeah, it looks like it didn't work very well. It doesn't have enough information in here. So I may need to install something for that to work. But we could try a different thing like GIF. No, doesn't like that. PNG is the one I'm used to, but I'm sure there's other ones. I don't, off the top of my head, I don't know.
I remember in the past I used to save as a PNG, but if you have a Unix system, you have to convert PNG to PDF. And I think with the EPS, I'm not sure if I'm right or wrong, but you have to have an Adobe program for EPS.
Let's see, matplotlib. Save fig. So yeah, there's stuff about it. I'd have to look into it, but okay. And then so I can save the figure. Now I want to save the data that I've made because I've generated some new data here. And where is that example? I think that's np save text. Oh, well, yeah, it supports EPS, but it didn't work, probably because there's something on my computer that's missing. TIFF is another good option. I would not use JPEG for any kind of figures. It's going to screw it up. Maybe I can save as PDF directly. That one might be interesting. Let's see, because Macs are very PDF friendly. Yeah, but there's something not working there. Maybe next time I'll have that working. Save text. Temps daily. That didn't work. Let's see. File name first. And there are my daily temperatures saved off. So we've got the whole loop. We can read data, save data, manipulate data, make a figure, save a figure. Those are the basic pieces for doing scientific computing. We'll get into a little more interesting things next time. If you have any ideas or suggestions, please email me. If anything was unclear, let me know. This is being recorded, so you can watch it again. Any questions right now before we stop?
Did you make your Python notebooks available?
I'll do that. I'm actually working on a website to do just that. So, okay. Thank you.